Very much, and hello everybody. It's great to be here with you today. So as previously mentioned, I'm going to be covering the role of food in the whole food system transformation. So just a bit of background context on the net zero. So the most recent analysis from the IPCC, the Intergovernmental Panel on Climate Change, found that really the best option, which within the context of the Paris Agreement, and adhering to the precautionary principle and equity components of that, would be to limit temperature rise to 1.5 degrees with no overshoot. This would require a 45% reduction in emissions by 2030 and followed by net zero by 2050. So if we don't act on food emissions, it would actually be impossible to meet these climate goals. The food system currently accounts for around 1/3 of all emissions globally. And on our current trajectories, would roughly double by around 2050. And a recent analysis from Science found that even if we stopped fossil fuel emissions tomorrow, we would still not meet the 1.5 degree target because of ongoing emissions from the food system. Put this into a bit more context. So the livestock sector alone on its current business as usual trajectory could use around half of the emissions budget for the 1.5 degrees goal by 2030 and around 37% of the 2 degree budget by 2030. Also, there are some technological improvements that could be made to reduce livestock emissions, but they're really nowhere near the scale of the challenge or the reductions needed. So reducing the production and consumption of animal products is really unavoidable in this system transformation. And if we did avoid that, it would actually require other sectors to do way more than is planned or realistic. And if we just look at that in a bit more context, so this is the emissions budget aligned with the 1.5 degree goal. And you can see there that with less than 10 years remaining of current emissions, there's really no wiggle room for any sector here. And this becomes even more apparent when we factor in addition to needing deep and rapid emissions reductions on the ground, we also need to remove massive amounts of CO2 from the atmosphere. So just to go into that a little bit more, this is essential for 1.5 degrees and most likely needed for 2 degrees as well. The options that have been mostly considered, or the most favorable options right now, require large areas of land. And there are numerous challenges in addition to that with the high-tech options. So here I'm mainly referring to bioenergy, carbon capture and storage. And actually the best option that we currently have available at the scale needed without sort of putting everything on hold until bioenergy, carbon capture and storage comes online or not, is actually reforestation or regrowing vegetation. Obviously, that does raise legitimate concerns around land use and this issue around food versus fuel, because that would still require massive amounts of land. But this is where we also really need to be looking at food and agricultural land in particular, because agriculture is the biggest land user globally. And within that, animal agriculture actually uses the bulk of this at 83% of that land. And this is in return for relatively little contribution to the global food system, so around 18% of all calories and 37% of protein. In contrast, crops use a much smaller amount, 17% of land, agricultural land, in exchange for by far the bulk of calories and protein to the global food system. So we need radical action far beyond anything that's currently planned across all sectors, and that certainly must include food. So what are the key elements of food system transformation? So we have things listed here, which I'll just run through. So first of all, we have some food related ones. So a shift to plant-based diets is really central in this, and it would really reduce impacts across the board. Food waste is also a really important one. So we currently waste around 1/3 of all food produced. And related to the point above, actually around 1/3 of all crop calories are wasted by feeding them to animals, essentially. So for example, it takes around 37 calories of crops to produce 1 calorie of beef. So this is another massive source of food waste in the system. We also have a couple of elements around land. So first of all, preserving existing habitats is really essential. So we need to keep those existing carbon sinks there as they are. And this requires us not to further expand agricultural land into those areas. In addition to that, we also need to restore some lost habitats, or at least a portion of the habitats that have already been converted to farmland previously. And we also need to produce food differently. So for example, precision agriculture to really reduce the need for chemical use in farming. And just to point out here that what we eat, so how far we go on that shift towards plant-based diets really determines the extent to which we can take up those land change options. And just to expand on that, this is an analysis that we published in September last year, which really demonstrates this diet and land connection. So here we use existing data from the published literature, and we mapped spatially agricultural land use for animal feed crops and pasture. And we then took the average from 6 vegetation maps to calculate the carbon that could be sequestered on these lands if returned to their natural vegetation state. So this is what we call the carbon opportunity cost of agriculture, animal agriculture, sorry. And this is what it looks like spatially. So this shows the carbon that could be removed from the atmosphere if pasture and feed crop lands were returned to their native vegetation cover, which in this example we disaggregated into forest and grassland. And the depth of the green colour varies according to the amount of carbon that could be sequestered, with the darkest shade here representing the biggest concentrations. And just to point out that this is the carbon sequestered in addition to that already being sequestered by the pasture, for example. And it might be surprising for some of you to see that what we think of as already quite green areas, such as Ireland, could actually be much greener in this sort of scenario. And in total, the sequestration amount is around 153 gigatons of carbon, which, as I said, is the carbon opportunity cost of animal agricultural production. And from that, pasture land accounts for around 72%. So in addition to looking at the sequestration amounts by region, we also looked at country income groups. And what we found is that around 70% of the sequestration potential occurs in high and upper middle income countries. And this is roughly split between cropland and pasture in high income countries, and around 70% from rewilding pasture in upper middle income countries. So there's really a huge amount of potential here for high income countries to take action. We also looked at diet shifts and the amount of carbon that could be sequestered if land was returned to its native vegetation cover. And what we found is that under a business as usual scenario up to 2050, we would actually be losing more carbon to the atmosphere due to further land clearance to feed an increasing population. But also this factored in optimistic future improvements in crop yields, but that was still insufficient to offset the expected large increase in the demand for animal feed. So under the Eat Lancet diet scenario, that second line on the chart there, second block, we could sequester around 332 gigatons of CO2, which is equivalent to around 9 years of current fossil fuel emissions. And if we extend that to the vegan diet, that increases to around 547 gigatons of CO2 emissions, equivalent to around 16 years of current fossil fuel emissions. And just in case anyone's not familiar, the Eat Lancet diet is around 70% less meat consumption compared to business as usual. So we also looked at this analysis for the UK, which we published in a separate report. And what we found is that the UK currently has around half of its land use dedicated to animal agriculture. And if we were to do this sort of ecosystem restoration approach in the UK, we found that if we restore native vegetation on animal feed cropland and pasture land, this would remove around 4.5 billion tons of CO2 from the atmosphere, which is equivalent to around 12 years of current UK CO2 emissions. So again, the darkest colour here represents the most dense sequestration amounts. And the majority of the sequestration actually occurred in pasture land, 73% in pasture land, mainly along the west side. And what we also found is that if we just restored pasture land, this would remove around 9 years worth of current CO2 emissions. And in either case, in either of those scenarios, it would actually make the UK agricultural sector net negative in terms of emissions. So if we transform food systems and do all of those 5 elements that I laid out, we would actually get around a 70% reduction in food-related greenhouse gas emissions. So this would be an annual reduction. And we would also get the 16 years of current fossil fuel emissions. So of course, this assumes that we go the whole kind of maximum on the plant-based diet spectrum. Just a few points on the time frame. So the annual, that 70% reduction is an annual saving from the emissions budget. There are short-term impacts from the methane removal. So methane currently accounts for around a quarter of today's warming. And the impacts could be within about 10 years in terms of impacts on temperature. The livestock sector is responsible for around half of all global emissions. So it expects that to be quite a significant impact. There's also the long-term impacts from the removal of CO2 emissions via the ecosystem restoration. And again, just to point out that the diet shift is really the most crucial element in here in terms of enabling, being responsible for the bulk of that 70% reduction, but also enabling that land sparing component to restore ecosystems. So to conclude, all I'd really like to say at this point is that these issues need addressing urgently, and action over the coming decade is absolutely crucial, and it has to be on everything, including food. So those main reports that I mentioned can be downloaded from these links. The global analysis, this is a read link, which I can also post in the chat. And thanks everybody for being here. I'm looking forward to the rest of the speakers and the discussion. Thank you.